Hey everyone, I wanted to do this video today on vertex form quadratics. Um, First thing I want to do is talk about what does the vertex form look like. Okay, it's the first equation on the left here. Y equals a parentheses x minus h squared. So, um, so that's what's called the vertex form, and then there's a specific equation that's specific to a particular parabola called that's y equals 1/2 x minus 2 squared minus 3. So the reason why this is called vertex form is because it makes it easy for you to identify what the vertex is from this type of an equation. There's another type called standard form, and in order to find the vertex in standard form, you have to go through a little bit more trouble. But standard form also has some advantages as well. We'll cover that when we get to standard form. But vertex form is this form right here: a x minus h squared plus k. So let's just jump in. So the vertex, okay, the vertex is always found. It's always found, and this is what makes it so easy. Vertex, first of all, what is a vertex? A vertex is a point on the graph, and it's an xy coordinate pair. Well, the beauty of vertex form is that the vertex is found at h comma k. All right. Now I've written down xy and now I've written down hk. So you guys are probably already a little bit confused. But the form is um, x minus h squared plus k. So if we look at this example and we follow the pattern, we've got x minus h. Here we have x minus 2. So we can deduce that our h would be equal to the value of 2, right? Because it's x minus h, and here we have x minus 2. So that means that h and 2 match up, okay? So, so the x value of our vertex will be at 2. Now, over here we have plus k, okay? And here we have minus 3. So what we can say is that minus 3 is really the same thing. It could be rewritten as plus minus 3, okay? These are equivalent expressions. Minus 3 is the same thing as plus of a minus 3, which means that k is minus 3. So there you have it. If you must know how to find the vertex is found at h comma k, okay? And it corresponds to an xy value. So let's go ahead and plot that. So I come over here to my grid and I go to 2 in the x and down 3 in the y. So that would put me right here, and I can put in my vertex. So that's going to be V, my vertex. Okay, so um, so can I find the vertex? Yes, check. All right. Now, the next thing is this thing called an axis of symmetry. So while I prepare for showing you how to do axis of symmetry, take a few seconds to make sure you understand how I found h and k and then plotted it. Now, the axis of symmetry. Okay, so what is an axis? Well, first of all, an axis is just a line, right? We on this graph, we have an x-axis, right? We have a y-axis, and these are kind of special, right? Because they mark off, x direction and y direction, okay? But an axis is just a line, okay? So an axis of symmetry, which I'll shorthand as AOS. Okay, it's just a line. Now, all the parabolas that we're working with here are either upward opening or downward opening, but what we would call vertical parabolas. Therefore, the axis of symmetry would be a vertical line. Okay, so vertical line. All right. Now, all vertical lines have the form x equals some number. Okay, x equals some number. All right. So let me tell you something else about axis of symmetry, and you should write this down in your notes. Okay, the axis of symmetry is a line that goes right down the middle of the parabola, which means that it goes right down the vertex. Okay, right through the vertex, I should say. Okay, so it's easy actually to know what our axis of symmetry is. If the form is x equals something, well, what would it be equal to? Well, since you know now that it goes through the vertex, then it would also be going through the x value of the vertex, which in this case is 2. Okay, the vertex is at 2 minus 3, but the x value of it is 2. So the axis of symmetry would be a line called x equals 2. And what I'm going to do now is I'm going to use my little line drawing tool here. So I'm going to go here and select my line, and then I'm going to make it dashed. And what I'm going to do is I'm going to start here and go right through the vertex vertically. Okay, now these things go on forever and ever. Okay, so it's not just going from minus x to plus 7. It actually goes on forever. Okay, so um, so again, it's a line that goes right through the vertex. Okay, and it's called the axis of symmetry, and it's found by using the x value of the vertex, and it's denoted as x equals whatever that value is because it's a vertical line. All right, so I'm going to come over here and I'm going to say, oops, I'm going to come over here and I'm going to use my pen and I'm going to say, check. We covered off on axis of symmetry, how to find it. All right, so take a moment to think about that, and then I'm going to get on with the Y-intercept. And then after that, I'll show you something pretty cool about axis of symmetry and some things that you can do with it. All right, so let me get set up for that, and I'll be right back. All right, now the Y-intercept. Okay, the Y-intercept is always defined for any kind of a curve, any kind of a line, anything, any function. It's where x equals 0. X equals 0. All right, so how do we find the Y-intercept? Well, what we have to do is we have to use the original equation, okay, which is y equals 1/2, okay, and then it's x minus 2. Now, if x is equal to 0, we would write in 0 minus 2, okay, and then we would square that, okay, because that's what the equation says to do, and then subtract 3, okay. Now, we have to do this according to the rules of PEMDAS, so y is going to be equal to 1/2, okay, times. Now, 0 minus 2 is minus 2, okay? And then when you square minus 2, you get a plus 4, okay? And then still minus 3. So 1/2 of 4 is 2, minus 3 becomes minus 1. So y equals minus 1, okay? Now, we come over here and we say that, well, first of all, the y-intercept is an ordered pair. It's where x equals 0 and y equals minus 1. So 0 minus 1 would be right over here. So I'm going to pencil that in purple, okay, right there, okay? So here's our y-intercept. This is our vertex. All right, and now I've shown you how to, calculate and find the y-intercept, okay? But there's one more thing I want to show you. this thing, this axis of symmetry, like I said, it goes right down the middle of the parabola, which means that if I have a point, any point, okay, that's not the vertex, it can't be the vertex, it has to be a different point. What you can do is you can go horizontally from that point, okay, either to the left or right, until you get to the axis of symmetry. And you can count how many units that is. So from here, it's 1, 2 units to here, okay? Now, because of symmetry, okay, I can go 2 more units to the right now, 1, 2, and I can plot another point at the same y value, okay, because the parabola is symmetric, okay? All right, so you're saying, well, what's so great about that? Well, what's great about it is if I went ahead and calculated a couple of points, then I can find more points that correspond to them by just using the property of symmetry, okay? And then I can pencil in my parabola. So what I'm going to do is I'm going to scoot over here and use a different color. Let's see, what color do you guys want to use? Let's use red. Let's use this color red, whatever that is. And I'm going to go ahead and use my pen. And now, starting here at my vertex, I'm going to kind of make a U-shaped curve starting from here. I'm going to go up and through that point and make it start looking like a parabola. And then from here, from the vertex, I'm going to go back out this way. That was not really as good. I don't go as well to the left as I go to the right, but that's all right. And there it is. You got your U-shaped parabola. It goes through these points, through the vertex. And there you have it. You learned today how to find the vertex, how to find the axis of symmetry, and the Y-intercept. All right? Any questions? We can cover off on those during class time. There are a couple of other things that I want to point out, but this is meant to be our first introduction to the subject, and I'll see you guys in the classroom. Talk to you later.